Today's topic is DC motor characteristics. Later I will be discuss the DC motor characteristics. Okay, we have know the DC motor are mainly three types. One, DC shunt motor, or shunt motor are also called separately excited motor. Second is DC series motor. Okay, third is DC component. I will discuss the DC motor characteristics with their plot. Okay, first we will see the DC motor equivalent circuit diagram. Okay, DC motor equivalent circuit diagram. This is the armature rotating part. Okay, the supply, here is the supply V. Okay, DC supply, and the supply current is I, armature current. Here is the internal resistance, that's called armature resistance, RE, as a back EMF AB. Okay, then we get the EMF equation. Then we get the EMF equation. Is equal to the EB is equal to back EMF equation. EB is equal to V supply voltage, V minus IA armature current into RA internal resistance. Okay, V minus IRA for shunt motor, and EB is equal to V minus IA RA plus RAC, or extra resistance are added in series with the armature unit. It's called, on this situation, this motor is called DC shunt or compound motor. This equation is series or series or compound motor. Okay, first then I will discuss DC shunt motor characteristics. DC shunt motor characteristics. Okay, this is the equivalent block diagram of DC shunt motor. I will draw. This is the supply plus minus voltage, DC supply. Okay, this is the field winding, this is the armature winding. This is the supply voltage is constant voltage. Okay, this supply voltage is constant voltage. Okay, this constant voltage is supply. When the constant voltage is supply, the flux distribution will also be constant in the field winding. Okay, when the supply is constant in the field winding, in the flux distribution to field winding is constant. Okay, the EMF equation, first we see the speed equation. We know speed equation, N is proportional E by phi, or N proportional E minus V by minus IRA. B is equal to, or back EMF is equal to let we can write EB is equal to Vt minus IRA by phi. Okay, here you can write n proportional, we can write phi is equal to flux constant because supply is constant, so the field winding flux distribution is constant, so the phi is constant, n proportional Vt minus IRA. Okay, this is number equation. Then we have the plotted the characteristics. Okay, first we will discuss speed versus armature current. Speed versus armature current. Sun motor. For sun motor, speed versus armature current curve for sun motor. Speed versus armature characteristics for sun motor. When I is equal to armature current is equal to 0, that's total point is 0, so we can write n is equal to Vt. Okay, n is equal to Vt. Then I will plot the characteristics speed versus armature current. This is the y-axis, this is the x-axis. Armature current, draw the x-axis, and speed you will draw the n-axis. Okay, when armature current I is equal to 0, the speed is equal to Vt. In that times you see that armature current when 0, the speed is maximum. Okay, the armature current 0, speed is maximum. Okay, so the n is equal to Vt. When n condition, the speed is Vt. Okay, hyperbola, and this is the rated speed, and this is the drop, IARA, this drop IARA. Okay, this drop due to IARA. Okay, this is the speed versus armature current plot. Second is torque versus armature current. So torque proportional phi into I. Okay, where phi is equal to constant. We know sun DC motor torque proportional phi into armature current, flux into armature current, where phi is constant because supply is constant. T proportional I. Okay, then we draw the curve. The x-axis I and torque is y-axis. Torque characteristic will draw y-axis. Okay, then torque is increased, armature current also increase. Torque increase, armature current increase. Torque increase, armature current is increase. This is a straight line. Okay, but after some time the armature reaction, okay, this is the straight line. Due to armature reaction, after some times the curve, this straight curve is slow down. Okay, reducing, this curve is reducing or curving, because after some time the armature reaction, the torque is reduces. This torque is after some time when the armature reaction is working, the torque is reducing, so the straight curve is, and the straight line is curved, slow down. Okay, this is the torque versus armature current characteristics of the DC shunt motor. Then we discuss speed versus torque characteristics of shunt motor. N versus torque. Okay, n proportional, we know n proportional Vt minus Ia Ra. Okay, flux by phi is constant. Okay, where T proportional, torque is proportional, or else I, this equation. Okay, and n is equal to Vt minus IRA. Okay, Vt minus Ia Ra. Vt minus I means torque T. Okay, Ia is equal to T into Ra. Okay, when T is equal to 0, torque is 0, then that time speed n is equal to maximum. Okay, when the time the curve x is for torque and speed curve is this. Okay, then I will discuss this all curve are characteristics of the Sun DC motor. Now we will see. Now we will see the DC series motor characteristics. DC series motor characteristics. First one, speed versus armature current. Okay, speed proportional Vt minus same the equation IRA by phi. This armature reaction is low armature, so low armature IRA is equal to 0. When is DC series connection, n proportional phi, n is proportional and the time n proportional 1 by I. Okay, when the time curve is I is excessive power and this curve is okay. Then I will discuss the torque versus armature current in DC series motor. Torque proportional phi into I. Okay, or the I proportional phi, because I proportional phi we have no. We can write T proportional phi. Phi means I. Ia into I means I square. Okay. The curve Ia and T. The torque equation is okay. I square then speed versus torque characteristics. N proportional Vt minus IRA by phi. We have no torque proportional Ia square. Torque proportional I square. So I is equal to K into I is equal to K into root T from this equation. Okay, into root T. Then we write, and we will write n is equal to equation from this equation K into Vt minus I. This equation will be put of I value. I is equal to K into root T into Ra by phi. Phi means K2 into root 2. Two constants, so that's called K1 and K2. Now this value is very small, so it is ignored. Okay, so you can write in proportional, this is constant, in proportional 1 by root T. The curve equation, torque axis बराबर y axis बराबर which is speed versus torque equation is this. Okay, this is the series DC motor speed versus torque, and this is the torque versus armature current equation characteristics. Okay, then I will discuss the compound DC motor characteristics. Okay, we have already known compound DC motor means series and shunt are combined are each other. Okay, so the characteristics also be like as series and shunt combined. Okay, so first we have draw the characteristics speed versus armature current. Speed in means speed versus armature current. Okay, axis for armature current is speed. Okay, for the series motor characteristics is this, and shunt motor is okay. Sorry, like this, armature current is the speed. Shunt, this is series, this is compound motor, and versus armature characteristics. Then I will draw torque versus armature current characteristics. Okay, this is the armature current, x-axis is the torque. For the shunt motor, the torque versus armature characteristics straight line, and series motor, this characteristics is this. Okay, the compound characteristics is this, compound motor, compound DC motor. This is the shunt DC motor series. Okay, then we will draw speed versus torque characteristics. Okay, this torque, this the speed, the characteristics is that's a combined. This is the for shunt, this for series, this is compound. Okay, all of the curve is the DC shunt motor, DC series motor, and DC compound motor characteristics. Okay, thank you.